guys. So today is about dilations on the coordinate plane. So yesterday we talked about dilations. How it either made the figure bigger or smaller. If it made it bigger, what number was it? More than 1. If it made it smaller, it was
Less than 1.
between 0 and 1. And if it stayed the same, it was what number? 1. Okay, so to dilate a figure on the coordinate plane, you multiply the x and y values of each ordered pair by the given scale factor. So they might give you an ordered pair. You might have to find the ordered pair off the graph, but a scale factor for an ordered pair, you multiply both the x and the y by that number. And then we just talked about this. Describe what you have when the scale factor is greater than 1. It gets larger. It's an enlargement. The scale factor is less than 1. Then it's a shrink. It gets smaller. All right, and then we also talked yesterday about to find a scale factor. So if they ask you, okay, here's this shape and this shape, what scale factor did they use? What we do is we take a ratio of the new figure divided by the original figure, or the image divided by the pre-image.
What's the difference between new and original image and pre-image?
That, so some people don't understand the words image and pre-image. So some people don't understand that pre-image is the starting figure, the original figure, and image is the figure after it's been translated. So they say original and new. So whatever one makes the most sense to you, you use.
They don't know their stems.
All right, so we're going to go into a problem here. So it says dilate the rectangle shown by a scale factor of 1/3 and record the coordinates in the table. So the pre-image is the starting image. That's the image they gave us. So we're first going to go through and figure out what those ordered pairs were. So I'm just going to put them in order, A, B, C, D. All right, so here's point A. Point A looks like it's at -6, +3. Point B is at +6, +3. C at 6, -3. And D is at -6, -3.
Lots of negatives.
All right, so those are the coordinates of the pre-image. I'm now supposed to take that pre-image and dilate it by a scale factor of 1/3. Do you think this figure is going to get bigger or smaller? Smaller, because 1/3 is smaller than 1. So I'm going to take this, and you can just do this in your head, but you're going to take each of those numbers, and you're going to multiply them by 1/3. So I'm doing that first one. So -6 times 1/3.
-2.
-2, because it's like 6 divided by 3. So -2. And then 3 times 1/3
-1.
is +1. Oh, it's positive. So you're taking the x and the y value and multiplying it by the scale factor. So the next one, 6 times 1/3. 6 divided by 3 is 2. So 2. 3 times 1/3. 3 divided by 3 is 1.
Can we start plotting these on the graph?
All right, the C point, 6 times 1/3 is 2. -3 times 1/3 is -1. You can use calculator if you need to, but multiplying by 1/3 is the same as dividing by 3. -6 times 1/3 is -2. -3 times 1/3 is -1. So are there any questions about how to change the coordinates? Right.
So I counted
You will. So what he's saying is he counted the squares on the sides, like the length and the width and the length, and then multiply that by 1/3. That does work, and I was going to get to this. That does work on straight lines. Okay. However, it does not work on diagonal lines. All right, so I'm going to plot my ordered pairs here. So -2, 1, So that's my A prime. Positive 2, 1, that's my B prime. 2 negative 1, that's my C prime. And negative 2, negative 1, that's the D prime.
That's small.
Yeah, because it became 1/3 of the original size.
Whoever did this is pretty mean.
All right, and then it says, how can you represent the dilation algebraically? So remember back to when we were doing up, down, left, right. If we were going up 2, then it was y plus 2. If we were going left 3, then it was x minus 3. So since we're doing a scale factor, we multiplied the x and the y by the scale factor, which was 1/3. So 1/3 of x, 1/3 of y. And that's how I would represent that algebraically.
Did we do y times 1/3?
It's the same. But it's not good math grammar.
Why are they letters in there? No,
All right. So it says, and this is where we're going to get into what Ryan was saying. Compare the ratios of corresponding sides and what do you notice? So looking at the bigger figure, that bigger figure there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And its side is 1, 2, 3, 4, 5, 6. And then the new figure, this is the original, this is the new figure, 1, 2, 3, 4, 1, 2. And it wants me to compare the ratios. So that goes back up to here on that second part. To find the scale factor, new over original, or image over pre-image. So the new figure's length is 4, and the original figure's length is 12. What does 4/12 reduce to? 1/3. If I look at the width of the new figure, it's 2. Of the original figure, it's 6. And 2/3 reduces to, or 6 reduces to 1/3. And look, what was the scale factor? 1/3. So you can check it by doing that on the straight lines of the figure.
My method also works. You know, where you add them all up.
Oh, yeah. All right. Number 3. Did the dilation change or preserve the orientation of the figure and the orientation of the vertices?
Change orientation.
Did the scale factor, the dilation, change the way the figure faced or the ordered pairs location?
No.
Yeah. Location.
No. Look, are they still facing the same way?
Yeah.
Are the A's, the B's, the C's, and D's are in the same spot?
Yeah.
Yes, so it preserved both. The only time that you're going to have where it changes the orientation, reflection, rotation, and it changes the ordered pairs are in a reflection and a rotation. But a dilation doesn't change the way that it faces or where the ordered pairs are, and neither does an up, down, left, right. All right, moving on to the back. Okay, up here at the top, it says dilate this figure by a scale factor of 2.
Excuse me, teachers. 6th grade band students need to go to the band room now for their instruments. 6th grade band students to the band room now.
All right, so E. E is at negative 4, 2. F is at 4, 2. G is at 3, negative 1. And H is at negative 3, negative 1. Now, do you all think this figure is going to get bigger or smaller? Bigger, because it's a scale factor of 2, which means it's bigger than 1, so it's going to get bigger. All right, so scale factor of 2. I'm going to multiply both the x and the y by 2. So that'll give me negative 8, 4. 8, 4, 6, negative 2, and negative 6, negative 2. So I just multiplied all the x's and y's by 2 because that was the scale factor. All right, I'm going to plot them. So -8, +4, so there's my E prime. 8, +4, so there's the F prime. G is at 6, -2, so there's G prime, and -6, -2, H prime. So I doubled in size there because it was a scale factor of 2. And then to represent that algebraically, how could I write it, Kate?
2x and comma 2.
Perfect. All right, I'm gonna let you all do number 5 all by yourself.
I can't do it. I don't even find this corner.
Yeah, go ahead and graph them too. Is this gonna be an enlargement or is it gonna be a reduction? Because 3/2 is bigger than 1. 3/2 is the same thing as what?
1.5.
1.5.
When I was in high school, I was every 3 years, and then I worked on the.
All right. So on this one, I, J, K. So I was at 0, 4. J was at 4, -2, and -4, -2. All right. So scale factor at 3/2. I'm multiplying by 3/2. So 0 times 3/2 is 0. 4 times 3/2 is 4 divided by 2, which is 2 times 3 is 6. 4 times 3/2, 4 divided by 2 is 2. 2 times 3 is 6. Negative 2 times 3 halves, negative 2 divided by 2 is negative 1 times 3 is negative 3. Negative 4 times 3 halves, that's negative 6. And then that one is negative, just already did it. All right, so 0, 6. I prime, 6, negative 3. J prime, negative 6, negative 3. K prime. All right, and then 3 halves X, 3 halves Y. If you put 1.5 there, I don't care.
I put X times C half.
All right, are there any questions about how to find the ordered pairs, multiply them, any of that? Moving on to 6 and 7, they give you the original image and the new image, and they want you to find what scale factor they use. So that goes back to that front question at the bottom, down here, where you take the ratio of the new to the original, or the image to the pre-image. And that's how you can find the scale factor. Now, what I was getting at when Ryan was talking about that, you can only use the straight lines. Okay? So when you're finding that, only use the straight lines. So don't use the diagonal. All right, so looking at number 6, was it an enlargement or a reduction? Did it get bigger or smaller? Bigger, because remember, L is the original, L prime is the new. Okay? So I'm going to count the sides here. 1, 2, 3, 4. And the side for the new one, 1, 2, 3, 4, 5. And I take the ratio of the new to old. So 5 over 4. Can you reduce 5 fourths? No, but you could divide it. 5 divided by 4 is 1.25. So either way, I don't care. So either 5 fourths or 1.25. All right, number 7. The prime is the new. The one without the prime is the original. So the only one that I can use on this one is the bottom, that base, because they're the only ones that are a straight line to find that scale factor. So on the original, 1, 2, 3, 4, 5, 6, 7, 8, 9. And on the new one, 1, 2, 3. So to find the scale factor, I do new over original. So the new was what? No, 3. The original was 9. Reduces to 1/3. And that makes sense because the figure got smaller. 1/3 of the size.
I thought the big one it doesn't have the prime.
It doesn't have a prime on it. The prime is the new. Right, Audrey?
Someone doesn't.
The prime is the new. It's new over old. So like on the front of your paper where it says scale factor, it's always the new over the original.
So what happens if the shape is like a diamond? How are we gonna find the scale factor of that?
You could probably draw a line between the middle. All right, the last part here. Find the scale factor that was used to dilate each of the points below. So this one just gives me points. It doesn't give me a picture, but it does tell me burden. It does tell me that S and S prime. So I know that S is the original, prime is the new. So I can do that ratio.
7th and 8th grade choir members, please report to the gym. 7th and 8th grade choir to the gym.
Is that anybody else? All right. So all right. So new over original. So you could do the X's or you could do the Y's. It doesn't matter. So 6 over 9. New over original. 6 9 reduces to 2/3. But if Burton, who talks a lot, he wants to do the y, so he does 8 over 12. Well, 8 over 12 reduces by 4, which is still 2/3. So the scale factor is 2/3.
Why not some blocks?
All right. On the next one, t is the original, t prime is the new. So you can choose either the x's or the y's. You can't mix them together though. It's either a ratio of the x's or a ratio of the y's.
But I just mixed them together on the board.
All right, so I'm gonna do the x's. So I'm gonna do 12 over 10. So 12 over 10, that can be reduced by 2. So that's 6/5. You put that yeah, or you could put 1.2 would be perfect. All right, and then the last one. This is the original because it's u prime is the new, and you cannot do the y's on that one. The 0 over 0, you can't divide by 0, so you're gonna have to use the one with the numbers. So -9 divided by -1, which is, in math, you can't divide by 0, it's under 5.
Well, I seriously, so we talked to us, no,